Hi, this is Tadessa. Welcome to a complete course in calculus. So in this video, we'll see some examples of a limit as well as how to find the absolute extrema on a closed interval. So let's start with the first example. The first example says, find the limit of radical of x plus 1 minus 3 divided by x minus 8 as x approaches to 8. So as you can see here, if you plug x equal to 8, the denominator will be 0, so it's undefined. So whenever you see this kind of expression, what you need to do is rationalize the numerator in this case. So how do you rationalize it? This is what you need to do. Just multiply the numerator and the denominator by the conjugate. So the conjugate means multiply by radical of x plus 1 plus 3 divided by x minus 8 radical of x plus 1 plus 3. And I believe I don't have to spend time on foiling the numerator. You know that the numerator is the difference of two squares. So when you foil it, that gives you x plus 1 minus 9 divided by x minus 8 times radical of x plus 1 plus 3. It's very important that you keep the parentheses, okay? So x plus 1 minus 9 means x minus 8 divided by x minus 8 times radical of x plus 1 plus 3. Now we do have a common factor in the numerator and denominator. They will cancel out. So that gives me the limit of 1 over radical of x plus 1 plus 3. See, just so keep in mind here, it has nothing to do with limit. What I'm basically doing is rationalizing the numerator. That's it. It has nothing to do with limit. Rationalizing the numerator. So now you can see that this expression here is defined at 8, so I can plug. So that will be 8 plus 1 plus 3, which is radical 9 plus 3, which is 1 over 3 plus 3. So the answer is 1 over 6. So that should be the limit. Let's see the next example. So the next example is limit involving sine. So note this. Again, you know the important limits. One of them says the limit of sine x over x as x approaches to 0 is 1. So we are going to use that. But in this case, it is sine 3x, okay? Can you factor the 3 out? The answer is no, you cannot factor, okay? You cannot factor. But here in the denominator I see 2, that I can factor out of the limit. So that gives me half limit of sine 3x over x as x approaches to 0. Now, because I have 3x here, I want to have the same I would say parameter in the denominator. So because this is x, I'll just multiply this guy by 3, and then I'll multiply this by 3. In effect, I'm multiplying by 1. 3 over 3 is 1, okay? That is what you need to do. So now I can factor the 3 out here. So this gives me 3 over 2 limit of sine 3x over 3x as x approaches to 0. So now, if you want to use change of variables, so what you need to do is say let theta equal to 3x. So I just call 3x to be theta. As x approaches to 0, if x goes to 0, 3 times 0 is 0, so which means theta will be going to 0. So this will be 3/2 limit of sine of theta over theta as theta approaches to 0. But now this is what we have here, which is exactly 1. That is how you should do it. This is a formal way of doing it. All right, let's see the third example, which says find an absolute extrema for the function f of x equal to x cubed minus 3/2 x squared on the interval -1. So if you remember, we have what is called extrema theorem on a closed interval, which says if you have a continuous function, continuous on a closed interval, then we have a maximum and a minimum. This is a polynomial, therefore it's continuous. So we have for sure maximum and a minimum. We have, but how do we find it? First, we need to find what is called a critical number. Okay, so what is a critical number? A critical number is a number in the domain where the derivative is 0 or the derivative does not exist. I will repeat it again. Critical number, Cn, What is a critical number? A number in the domain. It should be in the domain where the derivative is 0 or the derivative is does not exist. That's what the critical number is. So in this case, because it's a polynomial, the domain is negative infinity to infinity. So anything where the derivative is 0 or does not exist will be a critical number. Okay, so once you have the critical number, what you need to do is you evaluate the function at the critical number, you evaluate the function at the endpoints, then the maximum of this will be maximum, the absolute maximum, the minimum of this will be the absolute minimum. So the only thing is we need to find the critical number. So let's find the derivative. What is the derivative of this function? It is 3x squared minus, 3/2 times 2x, which is 3x squared minus 3x. This will never ever be 0 because it's a polynomial. So the only thing is I have to solve equal to 0. So this is 3x, x minus 1 equal to 0. So what is the critical number? This is equal to 0 means 3x equals to 0 or x minus 1 equals 0. So x equals 0 or x equal to 1. So these are the critical numbers, 0 and 1. So what I need to do is I need to evaluate the function at the critical numbers and the endpoint. So let's start with the critical number f of 0, f of 1. So if you plug 0, f of 0 is, it's 0. It's straightforward, okay? So if you plug 1, f of 1 means 1 cubed, which is 1 minus 3/2 times 1 square, which is 3/2. So the answer will be negative 1/2, okay? And then at the end points, f at negative 1 will be minus 1. I'm sure you know what I'm doing. I'm plugging these x values to the original function f. So that will give me negative 5/2. And then the last one is f at 2, which is 8 minus 3/2 times 4. So that gives you 2. So which one is now the bigger number? This is what the bigger number is. So this is what is called the absolute maximum. And the smaller number is negative 5/2. So this is what is called the absolute minimum. Thank you for watching. I'll see you in the next video.